Hi there. This video is going to be about tension. Tension is that force that you might feel on a tight rope. We're going to be talking about things as they are hanging from at an angle. That's the most often kind of way you're going to be doing these kind of tension problems. In class, we did a lab and kind of predicted what the tension would be. Tension is going to be a force, so it'll be measured in newtons. And we kind of looked at if you had things that are equidistant from each other, we saw that the force on this one might be x, and the force on this one is also x, if the object is hanging from something that happens to be the same length. But suddenly, when we changed them and we made them not the same, let's say x was maybe 2 times bigger, I know my picture doesn't really show that, but here we go, make it 2 times bigger, then we saw that the tension on the 2 ropes was not the same anymore. And so that kind of changed things up. And we couldn't even say that this one had 2 times the tension or this had half the tension. It isn't a multiplier like that. And the reason for that is that we've got angles here. And angles suddenly bring in sine and cosine. And sine and cosine don't work nicely like x and 2x. They've got sine and cosine with them. So that was kind of the lab that we looked at. And then we were able to look at some more complicated problems here. So here we've got a traffic light. The traffic light is 22 kilograms. And it's hanging from these 2 strings. One cable has a tension 1, and the other is tension 2. And so what our job was to find the tension on each cable. Now these problems do get a bit long, so hold on to your hats with that one. If it goes past the video, then I'll just make a new video here. But we'll see how we go. Please know that you can pause this at any time. In class, I would normally do a part of the problem, then I'd pause to make sure everybody can understand it. Well, in the video, I'm not going to be pausing so much, but so you're going to be the pause button. I'm just going to keep going right through. So please, please pause it as you go. All right, let's get started. Well, when we're looking at this kind of problem, we really got x and y that we've got to look at. So as we look down here, this is the weight of the object that's holding it down. And we know weight is the force due to gravity. The force due to gravity is equal to mass times acceleration, like all forces are. But since it's due to gravity, it's mass times acceleration due to gravity, or g. So in this case, if I wanted to calculate it, I know that my mass is 22 kilograms, multiplied by 9.8, and that gets me 215.6 newtons. Well, that's all good and all, but when it's 215.6 newtons, it doesn't mean that half of it's on this tension and half of it is on this one. We found that out in the lab, and once we start to look at things, you'll see that that's really not true either. So going back here, how do we solve that part? Well, if we take a look at this tension 2, it has a y component to it. This is the tension 2 in the y direction. And if I look at tension 1, make that green, it too has a tension of the 1 in the y component. Because each of these tension 1 and tension 2s are really vectors. And all vectors have an x and y coordinate to it. If we take a look at these 2 parts, suddenly I can see that if I add up the tension of 1y and the tension of 2y, then that's going to be equal to the full weight, which is in the y direction, of this traffic light. So that's kind of the first place I'm going to start here. I know that T1y plus T2y is going to be equal to the weight of my traffic light, 215.6 in newtons. But the problem is I don't know what T1y is or T2y is, so I'm going to do some math. And what I'm going to do is solve them in relation to T1 and T2. Once I've got that, then I'm going to have to go to the x category and solve for it. So this type of problem is like a systems of equation. I'm going to make one system equation and another one, and I can put the 2 together to solve for T1 and T2. That's my problem. Solve for T1 and T2. All right, so here we go. I'm going to start with this T1y here. I want to know what that value is in relation to T1. Well, if I look at T1y, I can see that it is in the opposite. It is opposite of the angle. Opposite over hypotenuse. So that means opposite over hypotenuse is sine. I know that sine of the angle, 37, 37 is equal to the opposite, T1y, over the adjacent, T1. In that same kind of spirit, if I want to look at T2y, which is something else I want to do, then I can look at the same sort of thing. That one is the opposite, T2y, over the hypotenuse, 2T2. And that will give me also the sine of the angle. In this case, it's 53 is my sine. So this will allow me to solve what my T1y and my T2y are. That's what I'm going to do next here. So sine, I'm going to take, let's do some math. I'm going to take this side over here and multiply by T2, and this side over here and multiply by T2. I'm going to put in my calculator actually what that sine 53 is. And sine 53 is 0.7986. That's sine 53. So 0.7986 T2 equals T2y. I'm going to do the same thing over here. I'm going to multiply both sides by T1. That way it'll cancel on the right, and I got T1 on this side. I'm going to put in my calculator sine 37, and I get 0.602 T1. So sine 37 of 0.602. T1, I just brought it to the other side. That's equal to T1y. Okay, so now I'm going to take these two values and put them into this top equation that I've got right here. Because T1y is 0.602 T1 plus T2y 0.7986 T2 equals that 215.6. So that's my first equation. That's very useful. Now, right now, you might be thinking, you just went from two different variables to a new two different variables. You're totally right. But now it gives me a chance to look at things in the x perspective. So let's look at things from the x. In other words, if we switch this up again, this part up here, this is being pulled inward. In other words, if you look at this corner, it's being pulled inward in order to hold the traffic light kind of in the middle of them. And it's being held in the tension in the x direction of T1x. And that tension has to be equal to the tension of T2 in the x direction. I know these two have to be equal because the sign isn't moving back and forth or any which way. It's not moving at all, which means those two tensions have to be the same. So suddenly I know that T1y equals T2y. Sorry, that's not y's, those are x's. Recap. There we go. T1x is equal to T2x. Going back up, the x's have to be equal since the sign isn't moving left and right. They're staying in one spot, so those two must be equal. All right, now that we know that, we're going to do some sine cosine kind of magic in order to get that in relation of T1 and T2. So when I look at x, I can see this is the adjacent over the hypotenuse. Adjacent over the hypotenuse is cosine. So cosine of the angle on this left side, it's 37. Cosine 37 is equal to T1x adjacent over the hypotenuse T1. In the same system, I've got cosine on this side, it's cosine 53 on the right, is equal to T2x over T2. I know it's cosine because this x part is in the adjacent, and the T2 is my hypotenuse. All right, just like I did before, I'm going to multiply both sides of this one by T1, so that cancels. Put T1 over here. Same idea is going on over here, T2, so they cancel, and I get T2 over here. Then I'm going to type in my calculator, cosine 37. I get 0.799 T1 equals T1x. I'm going to get my cosine 53. That equals 0.602 T2. And all that will be equal to T2x. Now this is really useful for us because I suddenly have two parts and they are equal to each other. That's what I established before. So now I know 0.799 T1 equals 0.602 T2. That's very useful. Do you see how I've got T1 and T2 in an equation? And up here I have them also. So now I'm going to solve for T1. Make sure I did that part in my notes like that. So T1 equals, divide both sides by 0.799. So 0.602 divided by 0.799. Let me check that one. And that gets me 0.7533 T2. Okay. Now that I've got that part, I'm going to take this, what T1 equals, and I'm going to stick it right in this top equation up here. I'll rewrite it to make it easier. 0.602. Now this represents T1, which I now know is 0.7533 T2. Plus, I'm going to add all the rest of the part. 0.7986 T2 equals 215.6. All right. Now I just got to do my algebra here. If I multiply these two out, I get 0.4535 T2 plus 0.7986 T2 equals 215.6. Now I add those two together. I get 1.25 T2 equals 215.6. Divide both sides by 1.25. Please pause this if I go too fast. And I finally get that T2 is 173 newtons. Or if you want to round it to 2 sig figs, it's 170 newtons. I got to one of them. That's great. I gotta go one step further though, of course, because this is just T2. And I do need to find what T1 is equal to. But I think I can do it. T1, I know, by looking right up here, T1 is equal to 0.7533 of whatever T2 is. And T2 is 173. So from that, I get it's 129, or in other words, 130 newtons using 2 sig figs. And I finally got to the end. All right, there you go for that one. Now we did do another one in class. It's all the same steps, all the exact same steps. The answers are right here. So I would definitely retry this one here on your own and see how you do. I'll post my work so you can see all my work for that and check how you did. If you need me to make a video for this, just let me know and I can do that. But I'm thinking when you see the work that it might work out okay for you. I'm at the end of this video almost, so I think I will just cut it off there. This is where we ended it today. We did another lab in order to figure out the mass of something, but you can't do the lab. So I hope that was helpful.